So we're going to be talking about the law of sines. Before, we were using trig ratios to find side lengths and angle measurements in right triangles. However, the law of sines and the law of cosines can be used to find side lengths and angle measurements in any type of triangle. So the law of sines shows the proportional relationship between angles and their opposite sides. And as I said before, it can be used to find side lengths and angle measurements in any triangle. So if we look at the left, we have triangle ABC, where capital A, capital B, and capital C are angle measurements, and the lowercase letters are side measurements. So if we look at angle A, looking at angle A, the side opposite angle A is lowercase a. So again, the law of sines is the proportional relationship between angles and their opposite sides. So we're going to have the proportion set up where we have the sine of angle A over little a. That's the opposite side. And then we have the angle B, capital B, is across from side lowercase b. So the sine of B over little b, and that's going to be equal to, we have angle C, and that is across from side little c. So sine of C over little c. So if we're looking at this first example, we have two angles. We have 71 degrees and we have 35 degrees. This 71 degree, the side opposite this one is x, and the side opposite this 35 is 12. So we're going to say the sine of 71 over x is equal to the sine of 35 over 12. Now we need to solve for x, and right now we have it in a proportion. So in order to solve for x, we are going to cross multiply. So x times the sine of 35, and then 12 times the sine of 71. So we're going to say x times the sine of 35 is equal to 12 times the sine of 71. We need to get x by itself. These are being multiplied. So we're going to do the opposite, which is divide by the sine of 35. Then we have x is 12 times the sine of 71 over the sine of 35. If you put that in a calculator, you'll get 19.8 for the decimal approximation. Let's try another example. Here we have our two angles. We have 114. Across from 114 is side x, and across from this 18-degree angle we have 5. So we're going to say the sine of 114, remember it's always the angle at the top and then the side at the bottom. So the sine of 114 over x is equal to the sine of 18 over 5. Again, we are going to cross multiply, and we're going to have x times the sine of 18 is equal to 5 times the sine of 114. Divide both sides by the sine of 18 to get x by itself. And now you have x is 5 times the sine of 114 over the sine of 18. If you put that in a calculator, you're going to get 14.8. Looking at this one, we have two angles. We have 73 degrees, that is opposite from 20. Then we have 59 degrees, that is opposite from x. So we're going to say the sine of 59 degrees over x is equal to the sine of 73 degrees over 20. And if you were wondering, you could have this written a different way and still get the same answer. So you could have had the sine of 73 over 20 is proportional to the sine of 59 over x, right in the reverse way, and you'd have still gotten the same answer, so long as your proportion is set up correctly. So we're going to cross multiply. We have x times the sine of 73 is equal to 20 times the sine of 59. Now we're going to divide both sides by the sine of 73. These cancel, and we're left with x is equal to 20 times the sine of 59 over the sine of 73. And if you put that in a calculator, you should get 17.9 for the decimal. Let's look at this next example. So this example is a little different because x is now inside of the triangle, which means that this is an angle that we're solving for, and we're no longer solving for a side. If you recall in the previous videos, we said that when we're solving for an angle, we need to be using inverse trig. So let me just write up here. We're going to be using inverse trig. So the proportion is going to be set up similarly, except this time, instead of x being on the bottom as a side, it's going to be used as an angle. So remember, it's going to be angle over the side. So x is going to match up with 9, and 77 is going to be with 14. So we're going to say the sine of x, because this time it's an angle, over 9 is equal to the sine of 77 degrees over 14. We're still going to cross multiply. So we're going to cross multiply here, and we're going to have 14 times the sine of x is equal to 9 times the sine of 77. So we still don't have x by itself. In order to get x by itself, we need to get rid of everything next to x. So right now we have a 14 and a sine next to the x. The first thing I'm going to do is get rid of this 14. Right now it's being multiplied, so I'm going to do the opposite, which is divide by 14. So I have the sine of x is equal to 9 times the sine of 77 over 14. It works easier if you get a decimal approximation for this weird looking fraction right here. So put this in the calculator, and if you do that, you'll see that you're going to get the sine of x is equal to 0.6264. Now we can use inverse trig, and we can say that that x is equal to the inverse sine of that decimal, 0.6264. And if you put that in a calculator using the inverse trig button, you'll see that x is 38.8 degrees. Let's try another example. So in this example, we have x still inside the triangle. It is opposite this side 15. And we have 126 degrees. That's opposite 31. Remember, it's angle over the side measurement. And again, x is an angle this time. So we're going to use inverse trig. So we're going to have the sine of x over 15 is equal to the sine of 126 over 31. We're still going to cross multiply. We're going to get 31 times the sine of x is equal to 15 times the sine of 126. Divide by 31. Let's get rid of that. Now you're going to have the sine of x is 15 times the sine of 126 over 31. Put this in the calculator. I spelled that wrong, but put it in your calculator. And you're going to get the sine of x is equal to 0.3915, which means x is the inverse sine of 0.3915. Put that in a calculator, and you will get 23 degrees for x. One last example. So we have our x. We know it's an angle, so we're going to be using inverse trig. We're going to be using inverse trig. Its opposite are 21. And we have a 61-degree angle. Its opposite, the 24. So we're going to have angle over the side, which means we're going to have the sine of x over 21 is equal to the sine of 61 over 24. I'm going to cross multiply. I'm going to have 24 times the sine of x is equal to 21 times the sine of 61. We're going to divide by 24. And we have the sine of x is equal to 21 times the sine of 61 over 24. Put this in your calculator to get a decimal. And we're going to have the sine of x is equal to 0.7653. I always take 4 decimal places because I want it to be as accurate as possible, but your final answer is what you can round to 1 decimal place. So we're going to say x is the inverse sine of 0.7653. And if you put that in a calculator, you should get 49.9 degrees. So remember to always check and see where your x is located. If it's inside the triangle, you're going to be using inverse trig. If it's outside the triangle, like this example, it's outside the triangle, you're going to be using regular trig. And remember that this is the law of sines, so you're always going to be using the sine function or the inverse sine function if it's inside the triangle. Don't use cosine, don't use tangent, none of that stuff. It's the law of sines, so you are using the sine function. That's all for law of sines. Next is going to be law of cosine.